So putting it all together now, we've got a form here for each of our main sine, cos and tan curves that tells us what to do when we've got a bunch of transformations to make. Now, you'll see here that sine and cos have a lot in common. Their period is 2 pi over whatever this number here is, n. And we know that sometimes we have to bring that n, whatever is in front of the x here, outside some brackets so that we can clearly see how it affects the phase. We also know that these two curves are the only two that really have an amplitude because that's the distance from the x-axis. And tan goes on and on forever, so it's not relevant to talk about the amplitude. Now, we can put A here and stretch all three of these curves vertically or compress them vertically. But for these two curves, it affects the amplitude, and we'll just say that the amplitude is A. For tan, it will be stretched. It won't have an amplitude, but it will still be stretched, and this number will tell you how much it's stretched. We have a mean value of C for both of these curves because they're toggling above and below a certain horizontal point. And so if the mean value is C, that's this number here, whatever we've added or subtracted at the end, which shifts the curve up and down. And for all of these three curves, we have a phase of B. So it doesn't matter which one they are, whatever is in here is the shift to the left. Now, if it is a negative number, it is actually a shift to the right, but we always discuss what the phase is as a leftward shift, even if it's a negative number. And the period, of course, for tan is different from the other two. It has a period of pi over whatever this number here is, n. Now we've got an example that brings all our skills together. So we need to sketch y equals half sine of 4x minus pi on 2 minus 2. And we need to also state period, amplitude, phase, and mean value. Now, whether or not the question asked you to do these things, it would be handy to do all four of those anyway because they're going to help us to make a sketch. Now, one thing you'll notice here, it's not quite ready. We need to prepare our function so that we can tell what number to use that's going to affect the period. This number that we've seen is n. And we can also see separately what the phase shift will be because the phase shift is not minus pi on 2 here. It's a bit of a trick. So the first thing that we have to do is rewrite it, and we bring that 4 out the front of some brackets, and that gives us, we've divided this by 4, so we need to divide this by 4, divide both of those by 4, and that gives us this. Now, to find the period, we need to use this 4, and we know that y equals sine x has a period of 2 pi over n, whatever number is here. So it would be 2 pi over, in this case, 4, which is pi over 2. So that means it repeats every pi on 2 in both directions. All right, next, our amplitude. Now that's just the number out the front of the whole function, and in this case it's half. So that means that instead of going up 1 and down 1 and up 1 and down 1, it's squinched in and being half the height. Now our phase, we can see now here, is we are moving to the left minus pi on 8. Now write that down, that is the phase, minus pi on 8. But what we've already seen is that there's lots of phases that will give us the exact same thing. So moving to the left a negative amount allows us to think of this two ways. We could either, when we go to draw it, move to the right pi on 8, or we could move to the left, and to find how far to go, we could literally add or subtract our period to this number to see what the equivalent phase shifts to this one would be. So if you've got minus pi on 8 and you add pi on 2, that's like having minus an eighth of a pi plus half a pi. Well, I know half minus an eighth is 3/8. So 3/8 of a pi, or 3 pi on 8, is the exact same phase shift as this one. This is a positive number, so it's telling us how far to move to the left. But I think you can probably appreciate now that if you move to the left 3/8 of a pi, or you move to the right 1/8 of a pi, that makes sense because the whole period of this thing is half a pi, or 4/8 of a pi. So you're going to end up with the graph in the same place. So use whichever phase you like. You can move to the right this far, you can move to the left this far. These are both acceptable ways to do it. And lastly, our mean value, well, the whole graph has been shoved down 2 units. So our mean value is -2. So it won't be going up and down around the x-axis, it'll be going along that line y equals -2. Now some small sketches to get you thinking. The one I like to draw first is just y equals sine of x. I know it looks like this, and it normally goes along with a period of 2 pi. But in this case, the period's pi on 2, and that gives me that x value there. Next thing to do, I know that this is halfway between these 2 points, so half of pi on 2 is pi on 4, and if I halve this again, I'll get my high point, that'll be pi on 8, and my low point, 3 pi on 8. So those are nicely locked in now, and I've dealt with the period. Now the amplitude, normally this point here would be 1, and this would be -1, but if our amplitude is half, then we have half and -half. So now that's done. Now we need to move it, shift it left or right. Notice how we've done both the dilation first, moving it this way, and the dilation this way first, and now we're doing the translations. So that's the right order to do things. Now, if I move left 3 pi on 8, all of my key points will move along 3/8 of pi. And this is sort of handy because I've done it in 8s, haven't I? Each one of these is an 1/8. I'm thinking it might be easier to think of it as just moving right 1/8. So that means that this point, if I grab another colour, is going to move along to here. And this point is going to move along to here, and this point will move to here, this one will move to here, and this one will move along past where I went to already. And obviously I can see what's happening now with my wave. This will now be a low point, won't it? So now I can see that my curve is going to need to look something like this. And I've got another point out here that I've made, which will be 5 pi on 8. So I've made my shift. And just to double check which one of these you used, if we'd moved our point instead of going 1/8 to the right, if we'd instead gone 3/8 to the left, 1, 2, 3, it's going to end up in the same part of the curve, no matter what. Alright, the mean value of 2 means that this needs to not be the x-axis. Instead, this is going to need to be, on our graph, -2. And that means if we're a half above this, this will be -1.5, and this should be -2.5. And so that means that we'll have our x-axis up here somewhere. So this quick sketch is helping me get things sorted so that now when I do a nice tidy version of it, I can hop straight to it. Now, the first thing I need is to get the axis right, so the labels. So let's go by halves here. -1/2, -1, -1.5, -2, and -2.5. These are the key points that I need. And I'm even going to put a dotted line coming along here for y equals -2, because that can act as this line that's coming through, and that would give me some nice places to put my dots. Alright, going this way, I'm going to build my graph all the way to 5 pi on 8. So if I say this is pi on 8, and pi on 4, 3 pi on 8, pi on 2, and 5 pi on 8, I've now got those 5 points that I've already considered. Now I need to start down here on -2.5. That's my low point. Pi on 8 is going to be right on the dotted line. Pi on 4 is my high point, so it's up here at -1.5. 3 pi on 8 is where I'm back going through y equals -2. And continuing down, I've got my low point, and then back to the midpoint again. And now I've got enough points here to sketch in my curve and just make it gently roll along like that. And they're all the key points that I need. There's only one intercept on my curve, and I've shown it. I've shown a bunch of other key points that can easily be lined up to see where they go. These dotted lines sort of help show exactly where things are. If you wanted to, you could label the points though.